Alright, so the upcoming question is from the chapter of application of derivative. Now, derivative is used a lot in physics and it is also used in all aspects of life. It is used in medicine, it is used in biology, it is used in almost every aspect. And this could include economics also. The numerical or the problem statement which is coming up also is from the same topic, and let us see how to solve these questions. One quick input is most of the students do a mistake that they are not able to understand that the derivative is instantaneous rate. It is only applicable for that time, a very small time interval, especially in the questions where the rate is with respect to time. So dy by dt is a rate of change of y with respect to t, and this dy by dt represents the instantaneous value of rate of change of y. This could be velocity, this could be acceleration, but it's instantaneous, remember that. So let's start this numerical now with this tip in your back pocket. Thank you very much. And let's read this problem first. Okay, Iqbal, a data analyst in social media platform, is tracking the number of active users on their site. So somebody is tracking the number of users on their website between 5 to 6 p.m. and on a particular day, okay? Because every day is not going to be similar. The user growth is modeled by nt is equal to 1000 e raised to power 0.1 t. So the way users are growing on the website has been mathematically modeled as this quantity, where nt represents the number of active at time t minutes during that period. Now this is what I wanted to tell you, that this nt is equal to 1000. This is the number of users which has been modeled. Is in fact it has been done for a time t. Okay, it says at time t, so at every time this is differing. This is the mistake students do. They're not able to understand that this expression, which is the model for user growth, is instantaneous in nature. Okay, now you need to find out. So this is not after time, after time t has elapsed. Time t has elapsed. This means time t is gone, and at t means this is only applicable for that particular instant. It is not applicable after time t has elapsed. So time keeps on elapsing. Maybe somebody says this is after 20 minutes. No, it is not after 20 minutes. It is at 20th minute, right? This is the language you have to use. At that instant. In the next instance, the user growth is different. This is the message which is coming from the equation. Okay, so at time t minutes during that period. All right. Now, how fast is the number of users increasing or decreasing at 10 minutes past 5 p.m. So after 5 p.m. 10 minutes will elapse and this will become 5:10 p.m. You have to find out what is the rate at which the users are increasing or decreasing, which means this is the user, right, value at an instant. You have to find its rate. Okay, so find how fast. Generally, whenever the word fast is used, it means the rate of change with respect to time. Okay, so what they're asking is dn by dt. This represents the rate of change of active users, and this again will come out to be an instantaneous value, and you have to find at some instant, which is 5:10 p.m. Let us see how to solve this. So dn by dt, if I take derivative of this is 1000 multiply by e raised to power 0.1 t multiply by 0.1 is equal to 100 into e raised to power 0.1 t and this is dn by dt. Okay, and so this is a rate, but you have to find at t is equal to how much? At t is equal to 10 minutes. Now if you notice, in the question t is in minutes, right? So if I put the value of t to be 10, okay, and this will tell me at the 10th minute, right, into 10. So this is equal to 100 into e raised to power 0.1 is equal to 100 by e. This is 100 multiplied by, you can find the value of e raised to power 1 by 10. This is going to be users per minute. Okay, now what you should be very clear about when you solve these questions pertaining to application of derivative is, so there is a quantity like y which is time dependent, okay, and you would be given an expression in the question. For example, in the given question, this was the expression, it was time dependent, and then you're expected to find dy by dt, okay, which is also time dependent. Okay, and you can see when I took the derivative, I still had a t here, time dependent. Most of the questions, in fact majority of the questions you get, the time dependency which is shown is clearly going to say at time t. So even the value of the quantity y is instantaneous, and the rate of change of y is also going to be instantaneous. This is the point that the students have to be very clear how the question has been articulated. The expression of the user being tracked on the website is this nt. It is not after time t that you reach this value. This is instantaneous value. If you read the question, it says at time t, at time t minutes, right? So this is instantaneous, right? For example, you're given v is equal to u plus 80 in physics. This velocity which you calculate, right, is after 5 seconds. Okay, so you can do velocity time graph. This is u plus 80. If you want to find at t is equal to 5 seconds, you can put the value here and you will get the instantaneous value of the velocity at t is equal to 5, and you can calculate as many as you want. You can calculate 5.1, you can do 5.2, you will get an instantaneous value, time dependent, right? And if you take a derivative of dv by dt, in this case you will get an a. So this is not time dependent, this is constant. But in most of the questions in application of derivative, the rate will also be time dependent. So be very careful when you solve these questions, that your focus is very clear, that you're solving the instantaneous things, and the rate of change of a quantity can also be instantaneous. So the rate of user growth can also be instantaneous. So you know, if I were to summarize this, I would say that not only the given quantity has an instantaneous value, but its rate of change is also a variable. It depends on time, keeps on changing. And this is, if you focus on reading the questions in a way that you are able to distinguish between the instantaneous values with other values, which are aggregated. For example, the values after a time of 10 minutes, etc., rather than at 10 minutes. That is where the distinction lies. So focus on the word at 10. So this will tell you it's an instantaneous value. This is not an average of previous rates which you are calculating. I hope I have been able to communicate some part of it successfully. You can watch some of my questions in the live playlist that I have for application of derivative, where you will find numerous such questions being solved. I know a lot of students do mistake in this topic, and therefore it is important to be very thorough in this topic of application of derivative. So do watch my playlist if you like this video. Subscribe to my channel, and thank you very much for your time.